Right now, I am pushing all the. I am pushing the original repository that we started with, which is the Build a Game repo, which you can see right here under github.com/techviagamespace/build a game wiki brainstorm or build a game basically. You should eventually be seeing the whole source code very soon. It's at 73%. It's not actually uploading anything, so I'm not entirely sure why it's being slow. But regardless, hey, now that we're here, let me just quickly talk over this, I guess. So if you go to my Bitbucket repository at bitbucket.org/Omiya Games, that's Omiya Games, no spaces. I think the O and the G has to be capitalized, but regardless, if you go there, you'll find a couple of different projects that I created, including the most frequently up-to-date, the Template Unity project. So that is what I'm copying over. It's usually what I start most of my Ludum Dare projects with, so go check it out. I'm just uploading that to the GitHub repository, so that's what we're pretty much waiting for. Oh, I pushed it. So if we go here and we check it, take a look. There it is. We did it. It's all uploaded. So yay. We have a make a game where the only way to go up is down, and a 3D maze, but can only see two of the three axes in three separate screens. Only see two of the three axes in three separate screens. I don't understand what this means.
Well, I think you can see it from one perspective in the XY plane, ZY, YZ plane, and the X plane, or XZ
right.
plane.
But you can only see two in the three axis, so maybe it's like I don't understand why only two out of the three.
Well, you just see different planes. It's projections, 3 different projections.
Let me think about that. Okay. Does it have to be a 3D maze?
Well, I guess a 3D game, but a maze would probably be the most straightforward implementation of this particular interface, or for this interface. But I guess you could probably do it with something else as long as it's 3D.
Right.
You might want to do a tutorial that's a maze, though. Just so somebody can get the idea, get their bearings.
Mm-hmm. Well, chat, I'm not really... This doesn't inspire me to make games. You gotta do better than this.
Yeah. Taco Phil says, no, just the idea I had.
Okay.
Excuse me. So Taro is thinking with an Oreo, right? Yeah, you're thinking with an Oreo, I thought.
I think, so actually setting up the whole, okay. Make a swimming game, got it.
Ah. Swimming game. Well, the other underwater theme. The underwater theme continues.
Right.
Sort of. Ooh, you could be on Europa.
Let me swallow that for a little bit. I think I have an idea.
I think that one's one with that.
Okay, let me put something together real quick. As a quick prototype, really. So this is not the project I want open. Yes. So one idea I have is being able to switch between different cameras, and as a consequence of that, it changes the controls a little bit. Open. We want our build a game. Yeah. Sure. Yeah, it should be fine.
Oh, make an Olympic swimming game. These interstellar games.
What?
I don't know specifically what that's referring to. Sorry, Gramps. You should do it like the subsurface ocean in Europa. It'd be so cool.
Subsurface.
Ocean on Europa, the moon Europa. It's one of
I see.
Jupiter's moons. They think
I see.
there might be might be life in it because it's got liquid water.
Mm-hmm.
Just a suggestion.
I think I have a few ideas. It's gonna be tough to implement immediately. Well, the first thing that I always do is check to make sure that I can actually make the prototype itself. As you can tell, making 3D games is actually kind of hard. So, hey, we're going to try making a kind of hard game. Not in actually playing the game, as in like making the game itself is an act of difficulty. something I want to do real quick. Stop recording. No reason to record this. I may have forgotten to take out the rendering pipeline, which is going to be annoying. Yeah, I better take out the rendering pipeline before this gets worse.
Uh-oh.
But yeah, this is game development. You watch a progress bar. It's very exciting.
It's an important part. Waiting for your files and everything.
Yeah. Alright. Rebuilding library because it couldn't be found. It did import the renderers. Post processing, yeah, we should look into that. We're gonna remove this. We don't need this. I have found that creates more problem than it solves. With that, I'm not going to need a shader graph either. Probably not need that either for the time being. I think my library needs those. I might be wrong. Yeah, I'll update that. And then we can get started. Oh, the joy of game development. Can you feel it?
Keep getting stuck on an ad.
Huh? Oh, wow.
Yeah. Oh.
Updating to latest Unity. So if you're wondering what I'm doing right here, I'm using what's called a package manager. Not package manager, version control. This is source tree, which is a UI for Git or Mercurial. I tend to use Mercurial most of the time, but I'm using Git in this case. It was created by the also the same creator of Linux, but anyways, this probably explains why it's a difficult software to use. But anyways, it's kind of a backup system. Oh, there's mathematics. Well, I'm not concerned about any of these for now. I'm concerned about opening up the main scene. Oh, well. No, don't save. Oh, wow. What happened? Oh, I think I know what happened. Projects. Graphics. Oh, see, it fixed itself. Ta-da! Alright, well, I don't know what happened, but whatever. That magenta usually says the shader did not work out, which is fine. I'm gonna do something a little silly here. The license, open. Make sure this is a proper license before I upload it. Okay, this MIT from Matt Dean. Then I shall use it. No one will ever know. There's, oh no, post-processing is completely empty. Then I am going to do this and copy it over to here. See what happens. Probably absolutely nothing. I think it also provides some sample assets, so I should probably use those a little bit. Demo profiles. That's curious. Camera orbit, line controller, camera orbit editor, textures, both TIFF, specular, color, main, specular. Huh, really? It's just it. I'm curious if this works. Simple noise. Okay, so then on this cube, right now it is complaining that the material on it is missing, so it needs material. Let's say that I'm going to create a quick material here. Default material. That didn't do what I think it did, but that's fine. Tune standard. Ooh. Oh, interesting. So let's go to our scene here and drop that tune standard onto our cube, which it's not taking for whatever reason. There we go. See if it likes that a little better. So this is music I created for an old game. Yeah. What is it using for, what is this shader using for, figuring out the transition from one to the other? That's something that's curious to me. Yeah, this was gonna look terrible. Oh, that's gonna look terrible anyways. Interesting. Oh, interesting. That's another interesting value right there. We'll stick with not very smooth. Mission. Okay, so Fresnel has that. Interesting. Alright. Well, I imported some toon shaders, so yay. Then the second thing is we want to actually do something with this, which is a completely fair point. So, fun fact with the Unity cameras, it is very easy to create a 3-point perspective of a camera per se. So, earlier it said that I'll need to figure this part out. I'm gonna probably get inspired by all the stuff that was given to me, all the in regards to suggestions, but not at all do them in any, like, not exactly do it in exactly the way I was told to do it. But anyways, here it is. So we have a camera right here. It is using post volume, and we have this camera to work with. So I think what I'm gonna do is basically have it so this camera, it's currently focused at one location. What is this? This is screen overlay. Okay, so then that means that I can just draw, I can just duplicate these cameras right here, and then make it so that this camera right here is facing in the X. So we'll call this the XY camera. We'll also move this back. We'll have this camera actually be in the center of the world, or the main camera thing here, and then move this one 10 units back. We'll have this camera, this is positive Y, this is positive X. We'll have this camera look in this direction. There we go, that's negative 90 degrees. That makes the Y and the Z positive, so we'll call this Y and Z camera. And then we'll make sure that we move this in the right direction. There we go. And finally, this camera right here, we're looking from the top-down perspective, so this we'll probably want to rotate in this direction 90, and then there we go. Move this one up 10 units. There we go. And then this one will be the, since it's looking at the Y, and make sure that, yep, okay, it is. It has the top as a positive, so that's what matters. X and Z camera. So far, so good. And you're going to be looking at this game scene, and it's going to be like, that's not very useful information. Well, that isn't, you're right, but we can easily say the width and the height is 50%. So this will be on, we'll probably want that up a bit, there we go. And then this will also reduce the camera width and height right there, and then have it right there, and this one, we'll have that in this direction. So we already have now the 3 camera perspectives that we want. Yay! Yeah, that's pretty much it. Let's see, I think we'll probably want that set, and thus all 3 of these cameras, they do have the post-processing layer, so that's good. They do have the flare layer, so that's good. This will be our audio listener, good. And then just create I will say a sphere, and it'll be at the middle of the world, right here. This sphere will have our default material. Fantastic. And then we'll give this sphere a clear object to make it obvious that it is facing forward. That is not forward. This is forward. Then we'll shrink this like so, and make it really long, like so. So that's the direction our sphere is going to be facing. Should make it very obvious. Neat. Okay. So we should be able to play this and see that absolutely nothing is going to happen except music. And then I guess I want to do something really silly where the last camera on the upper right hand corner is just kind of there and circling around whatever. Yeah, you know what? I'm gonna do that. Duplicate the last camera, and we're gonna call this freestyle. And then it's going to take up the upper right hand corner for no particular reason. We're going to add our Cinemachine brain to that. And then we're going to add, well, yeah, under the camera here, I'm going to add a free look camera setting right here. We're going to do it, we're going to say follow the sphere, look at the sphere. There we go. And it's very confused. It doesn't know what it wants to do right here. Maybe free look was not what we want, just kind of like clear shot, state driven, blend, and virtual. I think I'll go with virtual actually. Yeah, I feel like that makes a better sense. Tracked offset, so this one right now says -10. I'm going to make it very intimate. Then just a little bit higher. Make sure that we're looking at maybe, okay, that's a little too far. Maybe a few units ahead. Actually, you know what? I'm gonna make it even sillier. We don't need brains. We can drop the camera right on the sphere itself. I'm clever. We'll also need to make sure that this is under a specific layer. So we'll call this the player layer and make everything here under the player. Yeah. And while all the other cameras actually render that, this one, it doesn't. It simply, where is it? Oh, here, calling mask. We're going to take out the player. There we go. So, yay, we did it. All right, so this is going to be our player right here. I'm gonna actually just create a sphere for the heck of it, and then copy over the default material here. Create a group. We're gonna call this graphics. Gonna remove all these other shenanigans and make sure that we got a rigid body. We're not going to use gravity here. And now that we have a player, we're going to call this player. We're going to give this a tag player. We'll give this the main camera, and none of these will get, all of these will be untagged. I guess this one should be under post-processing, yeah. And then we'll make a prefab here. So here we go. We have a pretty decent start, I say. So now the player can look around and you can see the cameras being up to date as a consequence of that. I mean, that's one way of doing it. Maybe 10 units is a little too far. We might want to, I don't know. Thinking about it right now. Well, anyways, now that we have this set up, one thing I could probably do is I have this flash canvas, which is not very useful right now, but what I could potentially do, okay, so there's an overlay canvas here, which is a screen overlay, that's fine. There's also a bunch of cameras right here, which I'm probably in need of removing a couple of these command buffers that don't need them. What I am thinking, however, is also saying, okay, so I think I know what's going on. Where is the profile for this? I don't want these post-processing effects. Yeah, there we go. We don't want thing yet. Bloom is fine, color grading, sure. Do we have a LUT? No, we don't have a LUT. We have no lookup textures. Darn. But now that we have this, we can then create a silly player script and then also a silly camera script. I'll go over what I have in plan. Let's start with a camera script. Camera script will simply be follow, target, and yeah, it will just literally follow the target. How are we on the stream?
Look, it's looking good. Oh. Taco Bell says make an in-universe fairy. But Gwen English is like, well, not Gwen, sorry. Greg is like virtual camera. Taco Bell, I meant more of its movement pattern. When Greg, music, crazy, seems fine. Okay.
Not very useful comments so far.
No, and we haven't had any more suggestions, so.
We need something to look at, so I'm gonna, I'm just gonna say target, and then, because it is the cameras, I'm going to be using fixed update on purpose for this. Target, and then I'm just gonna say transform dot position equals target dot position. Simple enough. Shenanigans. Follow target. There we go. And we're going to target at the player. There we go. So now, in theory, when the player moves, so does the camera. Sweet. We can add a few other tweaks to that formula, but regardless. And then I'm going to add the player script. Player move. Well, sure. Go with that. I don't like that script name, but whatever. That's on me. I have tortured myself to this terrible naming scheme. I shall live with the commitment of terrible decisions. This is the least of my terrible decisions I've made so far, so I'm just complaining for the sake of complaining. But anyways. Rigid body, we need you. Yes. So we don't need that serialized per se. Rigid body, which will be null for now. We need to get the component off of our script of this rigid body. And then we'll check to see on every fixed update. But I'm also going to do one other thing, which is unusual. Public enum axis, and we have the xy, the xz, and the yz axis. So we'll discuss what I mean by that on a later time. Axis. We'll leave that under a serialized field. And then under fixed update, we haven't imported the cross-platform controls yet, so that might be a good thing to import.
Taco Bell says juggles. Greg says cameras in late update. Yeah. Yo. Greg also says, I don't see what you're doing. Are there other primitives you can add to show what you're doing? That's what he said.
Oops. These are not what I want to add. So this. Materials, yeah. Starting with a camera perspective prototype. So what was about the late update?
Cameras in late update. I don't know. Sorry, I don't know the context. He also, after the primitives comment, he says a prototype on a level or scene. It's just a thing in the middle.
Here, late fixed update. I think that is a real. Is there not a late fixed update? No, apparently there isn't. We need to make an Olympic swimming the interstellar game. No. Why do you suggest such ideas? Anyways, I was supposed to import cross-platform stuff, which I believe when you go to the standard assets, that is an option. Yeah, I don't need a majority of these. There we go, cross-platform input, I do need that. Cross-platform input, I do need that. I don't need the waters. Don't need the effects. Don't need environments. Don't need fonts. Particle systems, I might want particle systems. Physics materials, actually I do want physical materials. I don't want prototyping. And utilities, that could be useful. Yeah, some of these utilities look useful. Sure, let's commit to that. This is exciting. Progress bar, the game, the most exciting thing ever. Alright, let's see if this done any good. It looks like we didn't get any compilation errors, so that's good. Stage selected. And we are going to add cross-platform input libraries from Unity standard assets. Yes, reload, please. Now we want from using Unity standard assets, cross-platform input. I think that's just it. Cross-platform input manager dot get access horizontal. That needs to be capitalized. Float horizontal. Then we're going to make one for vertical. Then switch on axis, case axis.xz. Is something going on?
No. Sorry, other stuff. Alright.
Default. And then default I'll work on later. But what we want for this is, because it's x and y, we're going to run with the assumption that we want the x and y. Body dot add because we're in water, I can goof this up as in any way I want. Let's say we'll need a float here. Move strength. Let's make that 10F. Let's add a vector, 3, move. It is more efficient to just set the vector variables directly like so. Performance. Here we have this. We're going to make that horizontal times move, force acceleration times time that delta time. And likewise, this is supposed to be xy. And then we can add a similar notation for this. Horizontal is going to be x, z. I think for YZ, I believe this is the YZ camera. Z will be the horizontal. I also goofed the naming scheme here. These should be, there we go. And then the X, looking from this perspective, horizontal will be the X and the vertical will be the Z. Okay, yeah, that looks right. So, yeah, this should work. Or then we can say body dot add force, and we'll say move and force mode of acceleration. And then on our player right here, we can add some drag. We'll pull in some good old 0.05 drag, like angular drag right now. And see what happens. Well, we can see our character move, but it's hard to actually see it.
There's nothing in the background, right?
Yeah. There's also the fact that it's not looking towards a direction we're actually moving, so yeah, there's that problem too. If we're moving in that direction, I wonder if setting forward is the right thing to do here. Yeah, it probably is. Vector 3 forward. Actually, yeah, is transform forward actually settable? It is, okay, interesting. Forward. I'll take these out for now. It would actually make the most sense to do this too. And then I can say if moved square magnitude is greater than 0.01 f. Be quickly lazy here. Then say forward equal move dot normalized. And then set that to forward. It's not going to look very natural, but that's fine. And then recalculate move with acceleration. So now we need to say move dot x times equals not horizontal. What's the word I'm looking for? Oh, speed. Time dot delta time, and then we need to repeat that 3 more times. So this should, in theory, work, and then we can further adjust that as necessary. It's not going to look exactly perfect here, but whatever. Okay, so it looks like it's working. That's a positive. Now, we probably want to pull in some sort of particle system because I can't actually see how I'm progressing here. So we're gonna cheat a little bit by Wildfire Steam Mobile. What does Steam Mobile do? That is not what I want. What about fireworks? It's not really what I want either.
Yeah.
You know, I'm just gonna make my own particles. Ragdoll. That is particle system. Yeah, that's great. I don't want. I think instead of a cone, I just want a box. And then emit from volume. That's good. I don't want any speed actually right now. Start speed 0. There we go. That's looking nice. Okay. And then position. That's fine. Scale. This is where we need to jack up everything. There we go. Look at that. All right. I'm having a good feeling about this. Emission right now, rate over time 20. I'm gonna bump that up to 500. All right, it does not like that.
That's a lot.
Yeah, let's switch that up to 100. Shape, size over lifetime. Let's, yeah, I don't like that curve. I don't like that curve either. Start with 0 first. There we go. Flat. Make you flat too. Oh no, why? Free smooth. Flat. There we go. I don't know why it says separate axis. I just want this. There we go. Look at that. All right. Perfect. Now we actually know where we are at. See? I don't like the skybox either. We should try making a different skybox. We're on a different planet, right?
Right. Europa is an ice planet. You can look it up and take a look.
So it's very, it's very dark.
Well, I can show you a picture. This is what Europa looks like. like that.
Oh, well,
Got a lot.
here we have a way of creating a skybox procedural. And so it'll look like this, and we need to go to our project settings, and then go to graphics. If I'm doing this correctly, it is. I'm not doing this correctly. Maybe it's under lighting. Yes, it was. Skybox. All right, good.
So you can kind of see maybe a bigger picture. So
Yeah.
that's where there's high mineral content, those dark lines.
I mean, it's mostly ice on the top, right?
Well, yeah, it's ice, but that's, ice with concentrations of minerals in it. And it's probably not ice the way we would quite know it on Earth, but...
I mean, it's very, 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 very cold
Yes,
ice.
and also under very different atmospheric conditions, and like not.
So here we're gonna change the sky tint real quick to red here. I don't think that's what you said. Saturn, right?
No, it's Jupiter.
Jupiter.
This
So
is a Jupiter's one of Jupiter's moons.
so Jupiter is a little more orange.
Yeah. There you go. Cool.
Yeah. Let's see where the sun is. There it is. We're gonna make the sun really large.
Okay. Whoa.
Atmosphere thickness is super thick.
It'll be kind of thin, actually.
Okay, really thin.
Yep.
And then ground is well, it's hard to tell because NASA deliberately color codes things to mean specific things.
Well, in this case, it'll be what it looks like to the eye, and they'll do that more with like nebula and stuff like that to try to bring out specific characteristics. But I'm pretty sure this is
what I have
natural.
so far.
Yeah. See, it says that was an approximate natural color, so it's not exact, but it's kind of
Something like this. Oh my goodness! Look at that exposure. Whoosh. We can probably decrease that ever so slightly. All right, there we go.
yeah, it's one of the Galilean moons. So it's discovered by Galileo. So it's one of if you ever look at Jupiter in a telescope, you can actually see them.
Neat.
Yep, and you can actually use them as time to tell time if you've got the, calculations for it.
Okay, those particles are supposed to not move at all. So as in, our character is really slow moving. Miller velocity, scaling mode, that's fine. Scaled simulation space world. There we go. Start lifetime. This should be random between two constants. 0.5 and then 10. Pre-warm. There we go. So our character moves way too slowly. That's yeah, way too slowly. Far too slowly. So that's fine. We can jack that up to 1,000. There we go. See, now we escaped the box of particles. Oh, okay. Yeah, and the drag is pretty terrible. We need to up the drag. I'm gonna make our creature really heavy here. I'm also gonna actually make the particle system follow us. Just seems easier. And the particle system right now is scaled to, what is the shape size? 50. Okay, that's fine. We're 1 meter large anyway, so kind of makes sense. Okay, so apparently 50 is not large enough. We keep exceeding it. 100, 100, and 100. Don't randomize any of those. And then I'm gonna say emission. We're gonna go for 200 after all. I'm gonna say also this lifetime has to be decreased a bit. Try that again. Yeah, that looks a little better. I'm not a huge fan of the fact that the drag is ridiculously bad. Okay, so we're gonna need 1. Yeah, the drag needs to be up to like 1-ish. And then the force acceleration needs to increase as a consequence of that. Okay, that's a little too fast. Slow down! Just add divide by 2 and try that again. I feel like that's a reasonable speed.
Oh, that's not reasonable.
Yeah. Alright, cool. So now we got that. We're gonna play around with this a little more. Random between 2, constant 10. There we go. Look at that. That's a little too large. Wow. We got parallax working right off the bat. You can actually see the directions we're going. And I'm probably going to want to adjust this a little bit. Oh, whoops. Gonna make a new section here called animations, header, animations. So how's the stream so far? You can actually see the graphics changing.
Yeah.
Turn.
Greg asked, can't you just change it while playing?
Hmm?
He asked if you, can't you just change it while playing?
Changing what?
I don't know. It's the last comment he made, so.
Oh, change the values while playing? Yes, I'm sometimes an idiot and forget that you can do that. That is a fair point. Vector3.lerp. Not left, lerp. There we go. We want to go to from transform dot forward to forward and time.delta time multiplied by turn smooth factor. Whoops. I pretty much know what's going to happen with that, so I'm not going to bother to adjust that. But now I get to do the big thing that I really wanted to do, which is add this really awesome UI here. Look at that amazing UI. You see absolutely nothing new. But the intent behind this is being able to select the screen, so you can click on a specific screen section of that screen and say that is the coordinate I want to control by. So let's say this is the controls controls menu. I'm just going to call it. And then we're going to create some images to make sure that I understood this properly. Yep, for that, I definitely understood this properly. What? Perfect. Okay, so we're gonna, this is the, which camera is this? It's hard to tell because, okay, so that's that, and this is that. Okay, good. So, call this image, but what I actually want is a button. And it's using an image here, but what yeah, actually, that's kind of what I want. And then the disabled color should be completely invisible. Normal color should be really dark. It's a little faded like this. Highlight color should have a similar fadeness, but really light. Fade duration, that looks good. We'll call this button X or YZ, I believe, to make sure that's the correct one. Yep, it is. Then we're going to create one that goes up a little bit. So, oh my goodness, so bright, the sun. I meant Jupiter. Jupiter. Why are you so bright, Jupiter?
That is a very good question. Well, it's reflective. I don't know. What's the albedo of Jupiter?
I'm obviously making fun of my own creation here, but still. Okay, I got the right one. Oh my goodness. This is very confusing. Oh, nope, that's not what I wanted. Button. Technically, these shouldn't be buttons, but toggles, actually, now that I think of it. It would not make sense to... Oh, whoops. No, that's good. I like this, actually. Leave it like that, but I want a toggle. And I want a toggle group here. Allow switch off. No, don't allow switch off. And then toggle transition. I don't want any transitions here. But what I do want is these colors. This one is just, that is not useful. Really? Really? Oh my goodness. No information about transparency here. Okay, that's fantastic. Well done. 7 out of 7. There we go. Then let's copy this. Let's destroy this. Paste this. Make sure that it's targeting the right graphic. There we go. Let's mark this as is on. Oh, interesting. Ah. Okay. I'll have to play around with that a little bit. But that's going to be on me. And then this one is going to be the last one under the XZ axis. And this will be plopped right here. Should be fairly easy and obvious. Yep, okay. And so, in theory, once I have this, I'll just make I realize why. Just create an empty. Copy that, because I'm lazy. And I'm going to call this as select camera.